Hello and welcome to all of you in my YouTube channel. So dear students, in this class we will study about transverse nature of electromagnetic waves. So dear student, before we study about this topic, first we discuss what is electromagnetic waves. So first we discuss what are electromagnetic waves. So electromagnetic waves is a wave that is capable of transmitting its energy through a vacuum. That means इलेक्ट्रोमैग्नेटिक वेव इतनी कैपेबल होती है वो एक एम्प्टी स्पेस में से भी एनर्जी को ट्रांसमिट कर सकती है. Basically, it produced by the vibrations of charged particle. That means electromagnetic waves चार्ज पार्टिकल की वाइब्रेशन से प्रोड्यूस होती है. So this is the little bit intro of electromagnetic waves. Now we start our topic. Let us start with the picture of ocean waves. As seen from the side, they look like sine waves. As seen from the top, the crust and the trough makes lines. So the same thing happens with the electric and magnetic waves, and since they are perpendicular to each other, they form a plane. They show a nature which is the transverse nature of electromagnetic waves. So this is the Cartesian plane in which the wave is propagating along x-axis and the electric field is along y-axis and the magnetic field is taken along z-axis. So in an electromagnetic wave, electric and magnetic field vectors are perpendicular to each other, and at the same time they are perpendicular to the direction of propagation of the wave. So this nature of electromagnetic wave is known as transverse nature of electromagnetic wave. So this is the diagram of electromagnetic wave of transverse nature. Dear student, now first I write its definition and then solve its derivation. So here transverse nature of electromagnetic wave. Transverse nature of electromagnetic short form is EM wave. So according to diagram, we already know we have two vectors. First is electric field vector and another is magnetic field vector. So electric field vector and magnetic field vectors are perpendicular to each other, and at the same time they are also perpendicular to the direction of the propagation of wave. So that means जो हमारी electromagnetic wave है इसमें two vectors होते हैं, electric field vector and magnetic field vector. वो दोनों ही एक दूसरे के perpendicular होते हैं, and at the same time वो जो हमारी वेव प्रोपगेट कर रही है ना जिस डायरेक्शन में, डेट इज एक्स एक्सिस, उसके भी परपेंडिकुलर होते हैं. सो हमारी इलेक्ट्रोमैग्नेटिक वेव इस नेचर को कहते हैं ट्रांसवर्स नेचर ऑफ इलेक्ट्रोमैग्नेटिक वेव. सो हियर आई राइट इन एन इलेक्ट्रोमैग्नेटिक वेव, इलेक्ट्रिक फील्ड and the magnetic field vectors and the magnetic field vectors are perpendicular to each other. Vectors are perpendicular to each other, and at the same time they are also perpendicular. They are also perpendicular to the direction of propagation of the wave, which is along x-axis. Propagation of the wave. So this nature of EM wave, this nature of electromagnetic wave is known as transverse nature of electromagnetic electromagnetic wave. So dear student, according to definition, we have two vectors. First is electric field and another is magnetic field vector. वो दोनों ही एक दूसरे के perpendicular होते हैं and at the same time they are also perpendicular to the direction of propagation. That means जिस direction में हमारी wave propagate कर रही है, which is along x-axis, उसी direction में वो भी उसके भी perpendicular होते हैं. तो इलेक्ट्रोमैग्नेटिक वेव की इस नेचर को कहते हैं ट्रांसवर्स नेचर ऑफ इलेक्ट्रोमैग्नेटिक वेव. So dear students, now I derive its derivation of transverse nature of electromagnetic wave. So let's start. So we know we have two vectors. First is electric field vector and another is magnetic field vector. We know that for electric field and magnetic fields vectors equations are del square E vector minus mu naught epsilon naught curl square E vector upon curl T square, which is equals to 0, which is our equation number 1, and del square V vector minus mu naught epsilon naught curl square B vector upon curl T square, which is equals to 0, which is our equation number 2. So dear student, here this is del square into electric field vector and here del square into magnetic field vector. So here we have two equations for this derivation where we use this equation in this. So from equation first and second where we use mu naught epsilon naught, we know C, which is equals to 1 upon mu naught and epsilon naught. So squaring both sides, so we get C square, which is equals to 1 upon under root mu naught epsilon naught whole square. C square is equals to 1 square upon mu naught epsilon naught. So we know 1 square is equals to 1 and here square is cancelled with under root, so we get C square is equals to 1 upon mu naught epsilon naught. So mu naught and epsilon naught is also equals to 1 upon C square. So in equation first and second we substitute the value of mu naught epsilon naught, where we replace mu naught epsilon naught with 1 upon C square. So equation 1 and second will become del square E naught minus 1 upon C square curl square E vector upon curl T square, which is equals to 0, which is our equation number 3. Similar for magnetic field vector, del square V vector minus 1 upon C square curl square V vector upon curl T square, which is equals to 0, which is our equation number 4. So dear student, now we use the solutions of this equation, that is equation number 3rd and 4th, by using waves in 3D, that is waves in 3 dimension. So here I write the solution of equation 3rd and 4th will be E vector, which is directly dependent upon R vector and T. R vector, here R vector shows position vector and T is time. So which is equals to E naught vector exponential I cap K vector dot R vector minus iota omega T. Sorry, here I is not iota.
which is our equation number 5, and same for magnetic field vector B vector, which is also directly dependent upon position vector and time, which is equals to V naught vector exponential I k vector r vector minus I omega t, which is our equation number 6, where V naught vector and E naught vector are our complex amplitude, of electric field amplitudes of electric and the magnetic fields, and magnetic fields, and k vector is the wave propagation vector, So in next we put the value of del and E vector. Now del vector dot E vector is equals to, we know del is equals to I cap curl upon curl x plus j cap curl upon curl y plus k cap curl upon curl z, and E vector is equals to E naught exponential I k vector dot r vector minus I omega t. Here I put the value of del and E vector. So now here we take the dot product of propagation vector and the position vector, which is k vector and r vector. So here k vector is equals to I cap kx plus j cap ky plus k cap kz, and we know position vector is equals to x I cap plus y j cap plus k cap z. So after solving we get k x x plus k y y plus k z z, which is the dot product of position vector and the propagation vector. We know I cap into I cap is 1, same for y, j cap, and same for k cap. Now we put the value of k vector dot r vector in this equation. So we get del vector dot E vector, which is equals to I cap curl upon curl x plus j cap curl upon curl y plus k cap curl upon curl z. Here small k comes, and here I cap E naught x plus j cap E naught y plus k cap E naught z into exponential I k x x plus k y y plus k z z minus I omega t. So this is the dot product of del vector dot electric field vector. Now we separate this equation with respect to x, y and z. So del vector dot E vector is equals to curl upon curl x E naught x exponential I k x x plus k y y plus k z z minus I omega t. Same for y axis, curl upon curl y E naught y exponential I k x x plus k y y plus k z z minus I omega t, plus for z, curl upon curl z E naught z exponential I k x x plus k y y plus k z minus I omega t. So in next step, we differentiate this equation with respect to x, y and z. We differentiate this equation with respect to x, this with y and this with z. So after differentiating, we get del vector dot E vector is equals to E naught x exponential I kxx plus kyy plus kzz minus I omega t into I kx plus E naught y exponential I kx x plus kyy plus kzz minus I omega t into I ky, and same for z. E naught z exponential I kxx plus kyy plus kzz minus I omega t into I kz. So in next step, we separate out I. So I kx E naught x plus ky E naught y plus kz E naught z exponential I kx x plus kyy plus kzz minus I omega t. So here we put the value of x I cap, y j cap and z k cap, which is equals to position vector. So this equation will become I k x E naught x plus k y E naught y plus k z E naught z exponential I. In place of kxx plus kyy plus kzz, we put the value of propagation vector and the position vector minus I omega t. So dear students, we know the dot product of propagation vector and the electric field vector. So here the dot product of K and E vector, K vector and E vector I kx plus j cap ky plus k cap kz. Here I E naught x plus j cap E naught y plus k cap E naught z into exponential I k vector dot r vector minus I omega t. So dear student, we can write easily. We all know that we can write these equations like this. So as we know, E vector, which is equals to E naught vector exponential I k vector dot r vector minus eta I omega t. So here we put the value of E vector. So del dot E vector is equals to I k vector E naught vector exponential I k dot r vector minus I omega t. So del dot E vector is equals to I k vector dot E vector, and same for del vector dot V vector, which is our position vector, is also equals to I k vector dot V vector. So from both these equations, we know which is perpendicular to the propagation vector. That means जो हमारा electric field vector है and magnetic field vector है, both are perpendicular to our propagation vector. So dear student, we know for vacuum our equation, that is del dot E vector is equals to 0 and del dot V vector is also equals to 0, because rho and J, which is our current density and volume density, are 0. Because so by using these, we put these equation values here, where del dot E vector is equals to I k vector dot E vector, which is the dot product of propagation vector and the electric field vector, and same for magnetic field, I k vector dot V vector. So by using this equation, our equations will become, therefore k vector dot E vector is also equals to 0 and k vector dot V vector is also equals to 0. So this show that our electric field vector, which is perpendicular to propagation vector, and magnetic field vector is also perpendicular to propagation vector, which is equals to 0. That means electric field and magnetic field both are perpendicular to the direction of the propagation vector, that is our k. So this means that electric field and the magnetic field are perpendicular to the direction of propagation vector, to the direction of the propagation vector, that is k vector. So this means, our जो हमारी इलेक्ट्रिक फील्ड और हमारा मैग्नेटिक फील्ड वेक्टर है वो प्रोपगेशन वेक्टर के परपेंडिकुलर है. दैट मींस जो हमारी एक्स एक्सिस के लॉन्ग वेव जा रही है उसी डायरेक्शन के दोनों ही परपेंडिकुलर है. तो इसका मतलब है कि हमारी जो इलेक्ट्रिक मैग्नेटिक वेव है उसकी जो नेचर है दैट इज ट्रांसवर्स नेचर. सो दैट मींस इलेक्ट्रोमैग्नेटिक वेव आर transverse in nature. So this is the end of its derivation. So dear student, I hope this will help to you. So don't forget to subscribe this channel, share this channel with your friends, and also share this video with your friends. Thank you for watching.